is consists of several microservices built upon one stack. So the popular code-based source from authentication home to API-based configuration injection attacks and robust as vulnerabilities we have used to I have implemented the OpenID connect function. The version will consist of authentication principle IJWT offers. Later, I have implemented protective overload and it enhances the reduce security risks and token security compliance with the standards or infection against connection device and enhance the user experience also. Secondly, I have addressed all the security headers and content security policy configured and improved course configuration in all the server files in the backend. Those are identified by code fields and using SAP tool.
222-00242 from group 76. Today I'll talk about my contribution to SC4030 assignment, fixing cross-site scripting or XSS vulnerability in our food delivery system. XSS is a common security issue where attackers inject malicious script into user-provided data like addresses or names, which then execute in the browser. In our app, this was a problem because fields like delivery addresses, phone numbers, and item names were rendered directly in JSX without sanitization. An attacker could add something like alert inside script to an address, and when displayed, it would run potentially stealing session data or performing actions on behalf of the user. I fixed this in 3 key fields. First, in order history.js, I imported DOM purify and sanitized the delivery address from address and phone number fields using DOM purify. Sanitize before rendering them. This turns malicious code into harmless text. Second, in active order.js, I sanitize the order ID, item names, delivery address from address and phone number for each order in the list, preventing scripts from the executing in the active order display. Third, in creator.js, I sanitize the card brand, last 4 digits, and use email when fetching the rendered payment details, ensuring no injected code runs in the order creation flow. For testing, I used a WASP SAP to inject payloads like script alert into addresses and item names, simulating backend responses. In the vulnerability version, alert popped up, confirmed the exploit. After the fix, the code rendered as plain text, no execution. I also tested with valid data to ensure the UI worked normally. Browser dev tools help verify sanitized output. The fixes improve the app's resilience against injection attack, aligning with the OWASP A3 guideline. Overall, I'll make our system safer for our users. Thank you.
To explain the main vulnerabilities I identified in my project and how fixed them based on AWSP Top 10 2021 standards. First, let's look at the lack of input validations and sanitization, which comes under OWSP AI injection. This issue happens when user inputs are not properly checked or cleaned before being processed. For example, attacks can send harmful data like access scripts or invalid IDs through public routes such as register or login. To fix this, I used the Express Validate middleware. It checks if data flows the correct format, for example, verifying if an email is valid, if a password meets the length requirements and IDs, and if IDs are in the correct object ID format. It also sanitizes inputs to remove the malicious character. After implementing this, when users send invalid or dangerous data, the system rejects its safety with the 400 validation error. This prevents injection attacks and stack trace to the user. This can reveal input system details that attacks could use to plan future attacks. The solution was to long detailed error securely on the server using console error and send only generic message to the client like a server error. This change makes sure no sensitive information is shown to users, but developers can still view details in server logs for debugging. Finally, finally, the third issue was missing real limiting, which belongs to OWASP A7 insufficient attack protection. Without real limiting, attacks can send unlimited requests to endpoint like register or login, which may lead brute force and denial of service attacks. I solved this by adding the express real limit middleware. So now each user can only send up the 100 requests per 15 minutes. If they exceed that, they receive a clear message saying too many requests, please try again later. This prevents automated attacks while still keeping application usable for normal users. So that's all my part.
I'm Satsara, and my contribution to the project focuses on improving API level and backend security in our food delivery system. Especially, I worked on three major vulnerabilities: cross-site request forgery, insecure direct object reference, and insecure file upload handling. The first vulnerability is missing CSRF protection. The original system did not include CSRF token in API request for operation like post, put, or delete. This made the app vulnerable to CSRF attacks where the malicious website could trick an authenticated user into performing unintended actions such as updating their card, deleting payment cards, or registering a restaurant. To fix this, I implemented CSRF token mechanism. Each page load the frontend fetches the CSRF token from API CSRF token and included it in all the API request headers as a XCSR token. On the server side, the token is validated before any state changing operation. After applying the fix, any forged request without the token returns the 403 forbidden error by effectively preventing CSFR attacks. The second vulnerability I identified is insecure direct object reference. The original code used specific IDs like order ID and cart ID were directly exposed in API requests, and attacker could easily modify these IDs to view or change another user orders or cards. I solved this by verifying the user ownership before displaying or updating data. For an example, in order history, I filtered order.user ID is equal to user ID. This ensures that the user can only see their own data. I tested this using OAuth SAP by modifying the request IDs by unauthorized access using blocked and confirming the fix. The third vulnerability I identified is insecure file upload handling. The driver registration feature allowed any files type or size to be uploaded, even malicious files like .exe. To secure it, I added custom validation middleware using Molt. This middleware only accepts images JPEG or PNG smaller than 5 MB. If someone tries to upload different off-site file, the server rejects it 400 bad requests. This prevents the attacker from uploading harmful files or causing the denial of service. In summary, my work strengthened backend security by enforcing CSR token, accessing control checks, and safe file uploading rules. These fixes align with the OAuth's top 10 categories, mainly broken access control and security misconfiguration. Thank you.